Hello, everyone. This is Lambda again. Today, and also for the upcoming 2 or 3 sessions, we would like to talk about the basic building block utility functions in almost all functional languages. Even these days, most of the modern languages, that is map, reduce, and filter. And for the first session, we'll like to talk about map, which is one of the most basic building blocks. And I believe that this has been used by and enjoyed by a lot of developers. So this is very a common topic, but I think we can go into a little deeper inside by implementing it, not using the built-in one. Um, I think it should be quite fun. So today we will go a little bit under the surface of this map function, try to implement it from the ground up. So let's try that. First of all, this is the built-in map function coming with Clojure itself. So this is a built-in map, and let's take a look how it works. Map utility function takes two arguments. The first argument is a function, and the second argument is a collection. Of course, this is not an actual data, but collection could be any type of collection. It could be array, a list, even set, map, even I'm talking about hash map this time. Um, any collections can come here. So, but this time we would like to use the most basic collection type, which is a vector. And vector is also called almost the equivalent thing to array in other languages. In Clojure, we don't call it array, but we call it vector. So we can give 1, 2, 3. This is a valid collection. This is a data collection containing integers, 3 integers this time. And f should be um, a transforming function. So f's argument is supposed to be the same type of this collections item. So for now, we can expect um, integer could be an argument, and then the returning type could be anything. But this time, for simplicity, we want to give int. Int is, let's take a look what int does. And int is just add 1 to the given number. And therefore, we can expect that the result of this map function will be 2, 3, and 4. Yeah. So this is the built-in map function works. And today, let's implement it ground up from scratch. First of all, map is still a function, so I'm using defin. And map, let's give apostrophe. So this is a different map, still looks like a map. And in the argument, the first argument can be a function. And just for simplicity, we will roughly call it f. And f can be anything passed into this function. And the second argument is a collection, something like that. But this is a functional programming, so we will be doing recursive function. And for simplicity, for now, I am having one more argument, which is a result. And this is a temporary argument that contains the transitioning data until the end of this function, which is a termination point. The result will be changing along with the collection. And but at the end, result parameter will be removed. I'm going to show that as well, but just for now, for simplicity, let's bear with this result parameter. So the very first step that we would like to do is take the first item from the collection. in this case number one, and apply the given function with it. So f and first item of collection will be doing this. So we're using this ink and 1, 2, 3. The first item, which is number one, is taken out and applied by ink. So that becomes 1 becomes 2 in this case. So this is what that means. But that is not the end. And once this is transformed, then this need to be passed into result but taken out of collection. So what we do is we are going to call itself again, which is map apostrophe, and f will be the same, of course. This is a function, so we don't change it. But the collection, we will be passing rest of the collection. And this result will be appended by this new value. So this is the form that we would like to call the same function. It's the self function. That will be the way we would call itself. But if we do this, just do this, then it will call itself endlessly. There's no terminations. So we would like to have a termination condition at the beginning of this function body. So open a new parenthesis and ask if collection has been empty. So it means we have taken every element from this collection. If we have emptied the collection, then we don't have to do anything further, but we would like to return the current result without doing anything. However, if collection has not been emptied out, then that means collection has something, then we would like to do this step. Let's test how it works for now. Ink 1, 2, 3, 4. Okay, so something was wrong. What I did wrong is I did not give the temporary parameter. I'm going to remove this result just a minute later, but for now, just bear with it. Okay, so 2, 3, 4, 5. But as we can see, this is not the same form as the original built-in map function. The striking difference is the third argument, and we don't really want it. This third argument needs to be only internal. It doesn't have to be called from the outside of the map function, map apostrophe function. So what we will do is using multiple arity feature of Clojure. I believe lots of other languages have this multipolarity feature here. That means we can make conditions, multiple conditions of a function body based upon the number of arguments. So we would like to have 2 arity conditions and 3 arity conditions. The 2 arity conditions will be just function and the collection that is parsed, like the original function. But the result, the internal process needs this result parameter. So in this 2-arity version of the function, by calling itself and giving a default value for the result. This way, we can call with this third argument, but we don't have to. Because if we call this map apostrophe function with only 2 arguments, the first version of the arity function will be called, and then this will call the 3 argument version arity function of itself, like so. So let's try to see how it works. Okay, it works, but it doesn't look that pretty. It looks actually a bit ugly because we have to ask about call, which is collection. Is it empty? And we want to give the rest of the call, and we want to have the first item of the call. So that is really wordy, and we don't really want it, especially when there is an amazing feature called destructuring of Clojure. So, destructuring means when an argument is given in the argument section of the function, we can already split it into smaller items for our needs. For instance, collection must be collection like this, but what we need is we want to break this collection down into first item, which is first call, and the rest of the item by rest call. But we can do this job already in here. So we can remove call and give a square bracket, and we can give x, which is the item that we don't know, and we can give and sign, means the rest of the item, and the rest of the item we can just simply call xs, a plural of x. In this case, this x is simply a value, not a collection, but this xs is a collection which contains the rest of the items. I can show you how it works with some quick example. So one, two, three. And this is a simple destructuring using a different let block. So if we are only returning the x, it's only one. If we do xs, that is 2 and 3, which is a collection. So this way, we destructured the collection into two different pieces, the first item and the rest of the items. And the rest of the items, we don't have to say this, we just simply say xs. And for this, the first item, we don't have to say first collection anymore. We can just give X because this X is the first item of the collection. But this one is becoming more interesting because if the collection is completely empty, which is like empty vector, for instance, or empty array, there will be no first item. So we don't even have to ask empty if the collection is. We can just remove it and we can just ask if there is X or not. But we have to be careful because we are just negated this condition. If X exists, we want to call this. If X doesn't exist, we want to just terminate this process and return the result. So we have to put not here. This way, if X doesn't exist, then return the result and terminate all the job. If not, then do this recursion. Yeah. So let's call the final version. Yeah, like doing so. Now I think it looks a bit better than the first version. What about we can do some other different experiment, map apostrophe, and we can give a function, and this time we can expect s, and s implies it is string, and string we can say hello and s, like so. And then the last item can be collection of names. Any names. And let's see what happens. So hello Vicky, hello Johnny, hello Monster. So this is map we just implemented, map function in Clojure from scratch. Um, the original built-in version of map has more cases, covering a wider range of, different use cases. But I think this is something basic building block implementation, so which it was quite fun to do. And I hope you enjoyed. If you have any questions, any comments, please leave in a comment section of this video. Thank you very much for watching. Bye bye.